This video discusses one method to solving a bearing application problem. Bearing is an important idea in navigation, and there are two methods for expressing bearing, and we'll discuss the first method in this video and the second method in the next video. So when a single angle is given, such as 164 degrees, it's understood that the bearing is measured in a clockwise direction from due north. So we're going to start with a due north line. And then if we were going 164 degrees, we're going to rotate in a clockwise direction that many degrees, and that would give us our bearing of 164 degrees. So when we see just one number, start at due north, rotate in a clockwise rotation for your angle bearing. With these bearing problems, I really think that the picture is super critical. So practice a lot of them, drawing out the picture. All right, so a ship travels 50 kilometers on a bearing of 27 degrees and then travels on a bearing of 117 degrees for 140 kilometers. We want to find the distance traveled from the starting point to the ending point, and we'll round to the nearest hundredth. We're going to start by carefully drawing our picture. So there's a ship traveling 50 kilometers on a bearing of 27 degrees. So for that bearing, we're going to start with a due north line, and then we're going to go 27 degrees in a clockwise rotation from that due north line. And I do my best to kind of draw it to scale, but it's never going to be perfect. All right, 27 degrees, and that's 50 kilometers. Then the ship turns and travels on a bearing of 117 degrees for 140 kilometers. So I need a new north line for the change in my bearing. And now we're going to go 117 degrees. So total, that would be 90. So 117 is maybe over here a little bit. And 140 kilometers. And the question is to find the distance traveled from the starting point to the end point. So we need this over here. That's what we're looking for. Well, I certainly do not have enough information to get started at this point. And at this point, we only know right-angled trigonometry, so I need to have a right triangle. Let's prove that we do. Let's see how we could do that. I'm going to extend this due north line, the second one, down. And you'll notice these two due north lines are going to be paralleled since they're both north lines. And then this red line here is a transversal. So we have two parallel lines cut by a transversal. When we have that situation, alternate interior angles are congruent. So that means that this little piece right here is 27 degrees. Great. Also, this second due north line right here, it's a straight line, so it's a straight angle measuring a total of 180 degrees. Therefore, we can find the second half of that angle, knowing that it's supplementary to 117 degrees, and that gives us 63 degrees. Well, if we add up 27 degrees plus 63 degrees, we get 90 degrees, and here we do have a right triangle. So I'm going to draw a breakout triangle to the side. Here's our right angle. This one's 140, this one's 50, and we're trying to find x. Well, for this, we don't even need trigonometry for it. All we need is to apply the Pythagorean theorem to relate the three sides of this right triangle. 50 squared plus 140 squared equals x squared. And we'll just plug that into our calculator, rounding to the nearest hundredth. We get x to be equal to 148.66 kilometers.